welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 2.3 entitled Getting Information from the Graph of a Function. And today we're going to take a look at the domain and range of a function. We're going to look at where functions increase and decrease. And then we're also going to find their maximum and their minimum values. So we have a lot of properties of a function that can be more easily obtained from actually looking at the graph than trying to look at the actual function or the equation itself. And some of those values are the domain and the range. Okay? A complete graph of a function contains all of the information about the function. It tells us which input values match the output values. And when we analyze a graph, we have to keep in mind that the height of the graph is the value of the function. So we can read off the values of a function from its graph. And that's better explained in this example here. We have a function t, and it shows the temperature between noon and 6 p.m. at a certain weather station. So as you can see, we got the graph going up and then back down. Okay, so we're starting at noon and we're going to 6 p.m. So find t of 1. So we're just going to read this right off the graph. Okay, now 1 means that's the x value that I'm going to put into the function. So I'm going to go down here to 1, and I'm going to come up here to right about 25. So t of 1 would be 25. T of 3, again, I'm going to go to 3, right up to about there, and that's 30. So T of 3 is 30. And then T of 5, go over here and go up. That's right at about 20. So T of 5 is 20. So we're really just finding the y values off of our graph. We're going over to a certain x value and then going up to a certain y value. Which value is larger, T of 2 or T of 4? Well, T of 2 is right here. T of 4 is right there. If it's larger, it's got to be higher on the graph, so T of 2 is larger. Part C says to find the value or values of x for which T of x is equal to 25. So I'm going to look at my 25 value right across here. You can draw that line if you need to. And there's two values, 2 times that value shows up on the graph. So that would be at 1 and at 4. And then for part D, find the values of x for which T of x is greater than or equal to 25. Well, I was at 25 at the first mark here, at 1, and then I'm above it all the way until we get to 4, where I'm equal to it, and then I drop down again. So I need to be between 1 and 4. Technically, you could probably say less than or equal to as well, depending on how you interpreted the graph and how you interpreted that information. Okay. And as we look at these graphs, this is a really, really important concept, and this is something that students tend to struggle with, is being able to look at a graph and kind of chop it up into the domain and the range. Now I know you know the domain is all of the x values and the range is all of the y values. So you have to get into a habit of kind of looking at the graph just at your x values or looking at it just for the y values. So this picture really does a nice job of chopping up the graph. So they have the domain, the function is just this little arc here, this little red arc. But the domain, they show it just being these x values from here to here. So where this function kind of drops down onto the x-axis, and over here where it drops down to the x-axis, whatever those values are, that's what my domain is going to be. And then the same thing for looking at the graph horizontally. My highest value is right here, and that goes over to the y-axis, and my lowest value is right here on the y-axis. So those would be my range values. Anything between those values would be my range. So when we're graphing and we're finding our domain and range, that's what we need to do. Okay, so for part A in our example 2 here, they want us to graph this function and then find its domain and range. It says use a graphing calculator, so I will do that. We've got the square root of 4 minus x squared. Okay, so y equals the square root of 4 minus x squared. Okay, let me just double check that. Square root of 4 minus x squared. Okay, so if I graph that, I might have to adjust my settings here. Looks like it was zoomed in for something else. So let's do zoom 6. Let's do a standard setting, which actually makes it a little bit smaller. But on the large screen over on the right, you can see my function. And it looks like it's going from -2 to +2, and it looks like it's going up to 2 as well. So to verify that, I want to get my table of values. There we go. And notice at -3, there's an error. And at +3, there's an error. So my graph really exists between those values from -2 to +2. So that would be my table of values that I would want to write down if I'm graphing this. You can write down the decimals if you would like, or you can just write down the whole numbers. Just for time, I'm going to write down just my whole values. And then to graph it, just draw a rough little graph. We have -2, 0, 0, 2, 2, 0. And then we have those decimal values in there too, so we got to make sure that the lines curve. At -1, it was 1.7, and then at +1, it was 1.7. So yeah, right about there, right about there. Okay, so it's kind of like a little semicircle. Now to find our domain and range by just looking at my function, I'm gonna just kind of chop it up like the diagram did on the previous slide. Okay, for my domain, I'm finding all my x values. Okay, so here on my x-axis, my graph goes from here over to here. It goes from 2 to -2. So my domain then would be all of the x values such that -2 less than or equal to x less than or equal to 2. You could write it in interval notation if you wanted to, from -2 to 2. You could write it like that. And then my range, let me switch colors for the range. Okay, is my y values. My y values, my graph starts right here on the y-axis and then goes up to this point on the y-axis. So that y value is 0 all the way up to 2. So I'm going to have all the y values between 0 and 2. And you could say, with set notation, you could write it that way as well. And hopefully you can see that on the table of values as well. We're going from 0 to 2, low to high. Same thing for the x's. I'm going from -2 to +2. So really try and look at your graphs choppy like that. Like chop it up where you're just looking at where the graph crosses the x-axis and where the graph crosses the y-axis. Okay, and there's the book definition, the book picture, and the book answer there for part A and B. Now when functions increase and decrease, hopefully you know that when a function is increasing, it's rising, and when it's decreasing, it's falling. So you can see in this picture here, the line rises as it goes from A to B, and then it starts to fall as it goes from B to C, and then it rises again from C to D. So we have an increasing function, and then a decreasing function, and then it increases again at the end. So when we're defining this, again, we want to kind of chop up the graph into those little regions where it's rising and falling. And you're going to kind of look at the x-axis. They did it in this other picture as well. We're going to kind of draw these lines down. So from here to here, it's increasing, and then it's decreasing, and then it's increasing again. So for example 4, it says to sketch a graph of this function, find its domain and range, and then find the intervals where it's increasing and decreasing. And I'm going to go back to the calculator. Let's see, we have 12x squared. Let me clear out this other one. So we have 12x squared plus 4x to the third minus 3x to the fourth. Okay, so if I graph this, okay, I'm kind of off on my window a little bit here. I can't see everything that's going on. So I could zoom and adjust my window if I needed to. I want to change my Y maximum. Just make it 40. And now I can see the whole graph, especially on this large screen on the right. It's really zoomed in fairly well. But now if I'm actually going to graph it by hand, I need that table of values. So I'm going to do second table and get my table of values here. Now notice that just the way it's set right now, I'm at -3. I have a value of -243. There's no way I'm going to make a graph that big and put that point on my graph. The next point is -2, -32. Same thing. That's not going to fit on my graph, but I'm going to put it on my table because it tells me the direction that the graph is going. Because my next value is positive. It's a -1, +5. That I can graph. 0, 0 I can graph. 113, even 232 I can graph. And then this 3, -27, I'm probably not going to graph that, but again, it tells me direction that my graph is going. So those are going to be the values that I want to write down from -3 to +3. And when I tell students about values that they're going to make for their table to graph, I kind of say include realistic ones that you know you can graph, and then at least one of those really wacky ones that you know won't fit on the graph, but will give you direction for your graph. Let's see, then I'm also going to have one other one, 3, -27. I was kind of running out of room at the bottom there. So then if I graph this, I'm not going to make a super duper accurate one because of the space here. But we could adjust our y-axis if we needed to. I could say that I'm counting by 5s or 10s. But let's see. I did like 5, 10, 15, 20, 25, 30, that would work. Okay. So we'll say that the y's are going by 5s. So if you're going to do this on a quiz or a test, make sure that you tell me the increments that you're using on your axes, and the x's were going by 1s. All right, so at -2, I'm way down here at like -32. And then at -1, it'd be at about 5. And I'm at 0, 0. I'm at 113. So right about there. And then at 2, I'm up at 32, so that's way up here. And then at 3, I'm way back down here at -27. So my graph is going to go like this. Remember, when you connect your points, you're connecting from left to right. Okay? So, I mean, it's probably slightly off just because I'm going by hand. I don't have nice, neat graph paper, but that's essentially what the graph is going to look like. It says sketch a graph. Okay? Now, when we find our domain and our range, I'm going to switch colors here in case I need to chop up my graph. For the domain, I'm not limited at all as to what values I can put in to the function. I had negatives and zeros and positives. This graph has arrows going down. I know they're pointed down, but remember those lines are going to spread to the left and to the right. So I'm eventually going to include all the positives and all the negative values on my x-axis. So really, my domain is going to be all real numbers. I'm not limited at all there. But the y's for my range, slightly different. Okay. Now, again, this graph goes forever as it goes down, so all my negative values are represented on the y-axis. But as I go up the y-axis, my graph stops right there, and that value was the 232. So my graph doesn't go beyond 32. So my range then has a limit. It's going to be all the y values such that y is less than or equal to 32. So again, thinking of the graph in terms of how to like chop up the x-axis or the y-axis can really help. Look at just the horizontal and then just the vertical part of the graph. Now, where the graph increases and decreases, again, that is kind of where we're going to chop up the graph a little bit. Okay. Now, I'm going to start to the left. My graph is starting over in negative infinity, and then it's coming up. And it's coming all the way up until we get to this point right here. Okay. So all the way down here from negative infinity up to that part, the graph is increasing. Okay. So it's increasing from negative infinity up to -1. And then from -1 to 0, there's the next little spot where it is decreasing. So then it decreases from -1 to 0. And I'm going to use solid brackets. I know I'm using a solid bracket for -1 on the increasing and the decreasing. And that's okay. That's an okay format because it's really doing both at that point. That's a point where you could consider it to be the last increasing point, or you can consider -1 to be the first decreasing point. So it could be interpreted both ways. So I'm going to use that solid bracket. It's still a solution. It's still a point on this graph. There's no open circle or anything like that. So I'm going to use those solid brackets. Okay, and then as I continue from left to right, now my graph starts to increase again until we get to 2. So my graph is going to be increasing again from 0 to 2 on the x-axis. From 0 to 2, I went up on my graph. And then from 2 all the way on to positive infinity, that's where I'm going to decrease again. So it's decreasing from 2 to positive infinity. And again, I want parentheses around the infinities, not the brackets. Okay, so I use the up arrow and the down arrow just as little shortcuts for increasing and decreasing. If you want to actually write the words, that's fine. I just did that to save space here. And there's the books version of the graph. And our last concept for today then is talking about the local maximum and minimum. Now, a maximum just means it's the biggest value on the graph. So it's the highest point. The minimum is going to be the lowest point on the graph. Now, this doesn't mean, though, where you have the high point and the low point that go on and on and on forever. The graph we just looked at, their lowest points would be negative infinity and positive infinity because the graph went forever down in both directions. So we're not talking about that part of the graph. We're talking about the part that we can actually see on the viewing window. Okay, so here's a good graph here. And as we're going up, when we get to this point right here, that's a maximum. And then we come back down, and then that's going to be a minimum. We come back up again, that's another maximum. Go back down, that's another minimum. Now, if it wants the largest maximum, we would go with the higher. If it wanted the lower minimum, we would go with the lower point. Okay? So you could interpret this graph a couple different ways depending on what they were asking. It could ask for the local maximums. So then you would want to write the 2 values at the top of these little curves. Or if it asked for the least minimum, then you would just write the 1 value for the lowest curve. But the maximums and minimums are going to be where the graphs curve. It's where they turn, where they kind of have those little bumps on them. And again, we only want to show what we can see within the viewing rectangle. So we're talking about those maximums and minimums that we can actually see, not this part that goes on forever or this part that goes on forever. We're not worried about that part. We're worried about this maximum and this minimum right there, right on those curves. All right, so our last example then is example 6. It says find the local maximum and minimum values of that function correct to 3 decimal places. So when you see that, I hope right now you're thinking, I have to do this on my calculator. So we're going to go to the calculator, go back to y equals, clear that out, and we had x to the third. What was the rest of it? Minus 8x plus 1. And I'm going to take a look at my table of values. And I'm going to arrow up just a little bit and see what else happens. Okay, now at -5, even at -4, this is my first value that's kind of wacky. Where at -4, -31, I know I'm not going to be able to put that on a graph, but it tells me direction. But then -3, I could graph, -2, -1, 0, 1. I could graph all of those values. So those I want to have in my table. 2, 3, 4. Okay, now +4 again. This is where I have a really wacky value there, 433. So I would stop my table there. So I want to go from -4 to +4 and write down all those values. So I'm going to make my table, x's and y's. You can use x and f of x if you would like to as well. We've got -4, -3, -1, 0, 1, 2, 3, and 4. Squeeze it in at the bottom there. So we started at -31, came up to -2, 9, 8, 1, -6, -7, 4, and then 33. Okay, so then that would be the values that I would want to graph. Let's see, my highest y value looks like it's 9. Extend it. And my lowest, besides my extremes here, was -7. Okay, so -4, -31, I'm going to be way off the graph. But -3, -2, it's right about there. -2, 9, it's up here. -1, 8, 0, 1, 1, -6, 2, -7, and then 433 is way up here somewhere. Okay, so at -4, -31, I was way down here, so this is where I'm going to start my graph and come up. Whoops, a little bit smoother line. Connect those two, and then come down. And then here for 4, I went all the way back up to 33, so I'm going to go way up that way. So again, very rough graph of the graph. I have graph paper in my room, or you can Google search graph paper and print some off for yourself. But it says to find the maximum and the minimum values correct to 3 places. So this is where my maximum is going to be. And this is where my minimum is going to be, down here. Okay, so I have to find those values. Now, on the graphing calculator, you can go to Second Calc, and it'll find your minimum and your maximum for you. So to find my minimum, I'm going to do option 3. And I want to just put the cursor to the left side and the right side of where I think that minimum is. And again, the calculator says left bound and right bound. That's just to tell you to put the cursor on the left side and the right side. Then the calculator will say guess. And remember, that's its way of saying, do you really want me to find this? And there you go, your minimum value. Now they give you the ordered pair. So the ordered pair is going to be 1.632 and then -7.709. Okay, so for your minimum, your ordered pair is 1.633 and -7.709. So your minimum value, remember, that's going to be the y value in the ordered pair, so -7.709. That's your actual minimum value. You put x into the function, this y is what you get out. So that's your value. And let's go back to the graphing calculator and we'll find our maximum now. So go to Second Calc again, do option 4 for your maximum. Maximum, probably should have done my maximum first so I didn't have to move my cursor so much, but that's okay. Okay, I have to be on the left side again, so I hit enter. Arrow over to the right side of where I think that maximum is. Hit enter, and hit enter one more time, and there's your ordered pair, -1.633 and then 9.709. So then your max for your ordered pair is -1.633 and then 9.709. But again, remember that value, your maximum value is the 9.709. Again, it's the y value in the ordered pair. So when it asks you for your minimum or your maximum value, you're finding the y value from that ordered pair of the max or the min. Okay, and there again is the book picture of the graph, just so it looks a little bit nicer than the one I drew by hand. And there's your set of homework problems to practice these concepts. Make sure you're using your graphing calculator. There are a lot of graphing calculator apps that you can get for your phones, or there's graphing calculators online that you can use as well, and we'll talk about some of those in class. But if you have any questions on the homework, come on in and see me before school.